Hello, this is another video on how to diagnose a damaged or binding steering cable. And really, I guess this isn't the decision. You're not going to use this information to make a decision on whether to replace the cable or not, because you have to actually destroy the cable to find out where it was bad. But I'm just curious to know, was it at the end close to the outboard, closer to the the water splashing and that sort of thing? Was it a kink? Was it a chafe through the external sheath of the cable, or was it up at the helm where the hub and steering rack are? So I've checked the cable all through its length, and there wasn't any kink, but there were two bends. One up at the helm where it leaves the steering rack. There was a bend right about there, and then there was another bend at the outboard end of it where it made a 90-degree turn to go out through the side of the stern of the boat. So I have a suspicion that the binding is at the outboard end, and the reason why I say that is because if I come up here at this end and I take a screwdriver, there's some play in that gear when I try and move that, or when I go like this. Let's see if I can do it this way. There's some play there. I don't know if you can even see those teeth moving when I... Anyway, this is not seized in there, which means there's some play along the length of this cable for some distance. So what I'm going to do is cut it off halfway and see if that tells me which end is bad, and I'll be back in a minute. Okay, well, continuing on with my dissection of this steering cable, this is the tool I use to tear the cable apart. It's a air-powered cut-off saw, and it works pretty good for cutting through things. And of course, whenever you're doing something with a tool like that, you should have a set of these on. Protect your eyeballs. So what I did was there's the end of the cable. I came about halfway and I cut it right there. And what I did was I cut around the plastic outer sheath, the wire, next layer, and then I cut through the nylon sleeve. And then this is the part that's supposed to slide. And it does indeed slide within the part of the cable that goes back to the helm. It's pretty not like there's quite a bit of friction there, more than I thought. So I was expecting that to be perfectly smooth, but anyway, there's some friction there. And then I came along, and halfway between that cut point and the the end that goes to the outboard, I made another cut and checked that, and I found that it was stiff there as well, like seized. I found a spot that it was seized. And so just to show you a dissection of the cable, there's the outer black sheath. Then if you peel off the black sheath, you get all these wires that are wrapped around, like these steel cable. It kind of looks like a cable type thing. Anyway, all these wires, they're not rusted, so I'd almost say they're stainless, but they don't look like stainless. So I don't know what kind of steel they are, but they're not kind of that shininess like stainless. Anyway, then when you peel those back, you're left with this nylon sleeve, and I don't know if it's exactly a nylon, but it looks like a nylon product. And so that is all part of the outer sheath. So this, the steels, and the black sheath is all part of the outer stuff. And then inside that is this cable right here. And at first it just looked like a solid piece of steel. But after I took a wire brush to it, I cleaned it off, you can see it's actually spiraled. And so I thought, well, I bet you that's just a piece of steel that's wrapped around other wires. And that's it. That's in fact what it is. So I peeled that off. Wow, this is a strong cable. Anyway, you can see where this outer layer peels off. When you peel it off, you're left with more steel wires underneath. So it's quite a complex cable. I'm not surprised they're expensive to make. And so my findings, okay. So this part of the cable from the helm halfway had more friction than I thought, but it was not seized. Here's the very end of the cable by the outboard. It is also not seized. For the first foot up, actually for the first 18 inches, it's not seized. I cut it in various sections to find out where it was actually seized. And so it seems to be that it wasn't any specific point that was completely seized. It's that the friction had just increased so much from about the 18-inch point in from this outboard nut right here probably another 1.5 to 2 feet in that way. And it's not that. Here's the thing. I think it's just basically a lubrication failure. I think water got in the cable from this end where the outboard connects. I mean, that's a big connector, and maybe there's some opportunity for water to get in there. The sheath was not cracked, so it's not like water got in some other way, but I think it got in at this end. Water seeped in here and settled in a low point in the cable and just caused some corrosion with this part of the metal right here. And once that corrosion built up a few thousandths of an inch, the friction on this against this nylon piece was just so extreme that it just was terribly difficult to overcome. So anyway, I was interested in what makes a steering cable, and now I know. And I was actually expecting to find that the inner cable had worn through the sheath at one of the bends, either at the helm or at the outboard end, at the stern end, and that's not the case. The cable did not wear through the sheath. It just simply was a lubrication failure. Okay, well, that's what it was.